Hello, I'm Mr. Howard. In this video we're going to work with basic synthetic division of polynomials. In the previous video we worked on long division, so we're going to do three of the same examples. In this video only we're going to use synthetic division instead of long division. So in the first video we did use long division, which we set up this way. So we're going to work the same problem here. Remember, if we did long division we would set it up this way and work through it just like we did earlier in the previous video. But with synthetic division there are a couple of rules that we have to switch around here, and the first and a very important one is that we have v minus 1 that we're dividing by here. Well, with synthetic division we have to take the opposite of that sign, so instead of a minus 1 we're going to start with a plus 1 right here, and we're going to put this little shape right there, that little L that's been flipped over right here to denote that we're doing synthetic division. Our next step is to write each of the coefficients of our terms in order here. So we have 1v cubed, so we have a 1 that goes here. We have a minus 3v squared, so that's minus 3 goes here. Then we have plus 3v, so that's going to be a plus 3. We're just doing the coefficients and then the constant here. And we have a minus 1 last, so that's just minus 1. Alright, realize that if we were missing any powers here, see we have a power of 3, power of 2, power of 1, and then our constant. It must be in that order because synthetic division is not going to work if you don't keep that in descending order like that. All of your variable terms in descending order of power and then your constant last. If you ever have a power that is missing, you must insert a 0 in its place. So let's say we didn't have this minus 3v squared, we would still have to put 0v squared in its place and put a 0 here, otherwise as a placeholder, otherwise the synthetic division wouldn't work. Okay, and the other rule is that, and this is very important, synthetic division only works if you're dividing by a binomial like this. A binomial, binomials have two terms, just like this, and the binomial must have only a power of 1 for that variable right here, and it must have a leading coefficient of 1. Okay, it's not going to work if it's anything else. So you must have a coefficient of 1. Alright? So if you look at the previous video, the fourth example we did, we were dividing by 2a minus 1. Well, that one won't work with synthetic division, and that's why we're not going to use synthetic division for it, because the leading coefficient of 2a minus 1 is a 2. Okay? So just so we're clear, 2a minus 1 is what we were dividing by in that last example. We have a leading coefficient of 2. It won't work. Okay? It has to be a leading coefficient of 1. That's the only way synthetic will work. Okay. With that said, let's get started here. So we have written the opposite of this sign, so a plus 1 here. We then put this little brace here, and then we listed each of the coefficients. We're going to leave some space right here. We're going to need that in a minute, and then we're putting a long line underneath. So now that it's all set up, here's what we do. We bring the first term down, so that's a 1. Alright, now we're going to multiply 1 times 1, okay, 1 times 1, and that result is going right here. So it's going right here. Now we're going to add these, so that's the opposite of what we were doing before. Remember, we used the opposite of this sign right here, and now instead of subtracting each of these, we're going to be adding, and you always add with synthetic division. Okay, so negative 3 plus 1 is a negative 2. Okay, now I'm going to multiply 1 times negative 2 right here, and that result is going right there. So 1 times negative 2 is negative 2. Now I add these. So 3 minus 2 is 1. Now I multiply these. So 1 times 1 is 1. That result goes right here. Now we have negative 1 plus 1 is 0. So we have a remainder of 0. Alright? So we're done when we get down to this last part. So we have a remainder of 0. And here is the key. Each of these, this one, and this one, are our coefficients and or a constant here. Okay, so the way that this works, if you started with a third degree here, so you started with an exponent of 3, you subtract 1 from that and then write those out using these values as your coefficients. Okay, I know that sounds a little complicated or confusing, but let me just write it out and hopefully it'll make more sense, and then we'll do some more examples. So we started with a v cubed. So my first term I'm going to write here is going to be a v squared, and this is the coefficient. This first one here is the coefficient of that term. So it would be 1v squared. Okay, I could leave off the 1, but just to show you what we're doing here, I want to leave it. And then it's minus 2, because our next coefficient is minus 2. After v squared comes v, so minus 2v. We're in descending order here. And then we have a plus 1, and after our power of 1 variable, we're just left with our constant. So here's our answer. So our final answer is v squared minus 2v plus 1. Okay? That is the same thing that we got in video 1, and that is the answer. So v cubed minus 3v squared plus 3v minus 1 divided by v minus 1 is equal to this, which means v minus 1 times all of this would equal v cubed minus 3v squared plus 3v minus 1, because multiplication and division are opposite operations. Alright, so let's look at example 2. I know there's a lot of rules and process steps to the synthetic division, but once you get it down, it's actually really quick to do any of this polynomial division in which you have a leading coefficient of 1 where you can actually use it. Alright, so let's move on to example 2, and hopefully that'll clarify it for you. Alright, here we have example 2. So we have x minus 2 is what we're dividing all of this by. So we have a leading coefficient of 1, so it's a candidate for synthetic division, so that's good. And remember, instead of a minus 2, we're going to use a positive 2 here. We'll do the opposite, use the opposite sign, put our little brace. Now we list each of these coefficients. So x cubed has a coefficient of 1, x squared has a coefficient of 1, negative 7x has a coefficient of minus 7, and then we have our positive 2, just like that. We leave some space, draw a horizontal line here, start by bringing down this first term, so we have a 1 here. Now, we are adding all of these. So now we multiply. 2 times 1 is 2. The result goes here. Now we add. 1 plus 2 is 3. Multiply 2 times that. So 2 times 3 is 6. That result goes right here. Negative 7 plus 6 is negative 1. Now we multiply 2 times negative 1. That's negative 2. Remember that result came from that. So 2 minus 2 is 0, so we are left with a remainder of 0. Now we have our answer. So it's fairly quick. You may need to watch this a time or two until you get the process down, but we're actually already finished, so it is faster. So we started with our highest exponent was a 3, so we're going to start with an exponent of 2. These are our coefficients. So I have 1x squared. I could just write that x squared, but I'm going to write it 1x squared to make sure you understand where this is coming from. Okay, I'm going to draw an arrow here so we know where that came from. 1x squared, and then we would have a plus 3x. That's our next. Remember, we have to decrease in order. Our exponent was 2. Now our exponent is 1, and that coefficient came from right here. And then we have minus 1. That is our constant. Minus 1. We had our squared term, then our first degree term, and then now we have our constant, minus 1. And that minus 1 came from right here. Okay, so to write it all out, our answer is x squared. I'm going to leave off the 1 now. So x squared plus 3x minus 1, and we are done with that problem. And that is the same thing we got in the first video, so we did check it there, so we know it's correct. Alright, so let's do one more. Remember, synthetic division is just about getting the process down, and then it becomes easy, and it really is faster than long division. If you have a situation where your polynomials are a candidate for the synthetic division. Alright, so let's look at the final example. Alright, we're back with example 3 here. So we have n plus 1 that we're dividing by, and we have a leading coefficient of 1 here, so it is a candidate for synthetic division. So we have a leading coefficient of 1 again, so that's good. We have n plus 1, so we need to use the opposite of this sign. So instead of plus 1, it's going to be a minus 1. Put our little bracket. Then we list our coefficients. So we have 1, -1, -3, and -1. We're listing coefficient here, 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 and then our constant in that order. You see we wrote it in descending order, or the question already was in descending order, so we didn't have to rearrange any terms there, but always check that to make sure these are in descending order. Alright, now we draw our line underneath and drop down this first part. We always have to do that first. Okay, now we multiply. -1 times 1, -1. We're adding these. So -1 plus -1 is -2. Now we multiply here. -1 times -2 gives us +2. -3 plus 2 is -1. Now we multiply that. So -1 times -1 is a +1. So that's going right there. -1 plus 1 is 0. So we're done. Our remainder is 0. We don't have any more coefficients or constants up here to bring down. So we're done. And our answer is we started with a cubed term, so we're going to start here with a squared term. So it's 1x squared. I'm just going to write it x squared minus 2x minus 1. All right, and there's our answer. We're done. And that is the same thing we got in the first video, and we know that is correct. Okay, let's quickly look at the fourth example and just discuss one more time why it's not a candidate for synthetic division. Alright, so here was that fourth problem that we worked in video 1 where we could do long division on it. We can do long division on any polynomials, but we cannot do synthetic division on this one because we are dividing by a binomial that has a leading coefficient that is not 1. This one, the leading coefficient is 2, so it's out with synthetic division. The only way we can do that is with long division. Alright, so I will see you in the next video. Remember, you can watch this multiple times if you need to until you get the process down. Once you get the process down, it's pretty easy. Alright, see you in the next video.